Okay, now let us look at this question. A 5000 Hz sound wave is emitted, emitted by a stationary source. This sound wave reflects from an object moving 3.5 meters per second towards the source. What is the frequency of the wave reflected by the moving object as detected by a detector at rest near the source? Okay. Assume the speed of sound. Again, this is some grammar mistake. Yeah, speed of sound in air is 345 meters per second. Okay, we need to analyze this question carefully. Okay, analyze this question carefully. If you maybe let us draw out the situation here, because if you look really carefully, this question has two parts. Yes, two condition happening. Okay, I want you to listen together with me. Yeah, do this question together. Okay, you see, first of all, he said this sound wave is being emitted by a stationary source. At first, the source is stationary. Okay, and this stationary source emits a sound. And this sound wave is then reflected by another object. The word here, reflect from another object, means the source is stationary, but the observer is moving. So here already become one situation. Here already become one situation. This is our first situation. Okay, our first situation. Okay, let us draw out this situation. Yeah, draw out this situation. Let us draw out this situation. We have a source. Okay, we have a source here, stationary source. Okay, at first the source is stationary. This is our first situation. I drawn already the picture for you. This is the, he said the first situation is the source is stationary. Source is stationary. He emit the sound wave of 5000 Hertz. This is the source frequency lah. Okay, I can say this is the source frequency. Okay, the source frequency here is 5000 Hertz. Okay, the actual frequency, the original source frequency. Okay, and then he said the sound waves is reflects. Reflects, that means he reflect the reflect whatever's observed frequency. Okay, he reflect the frequency, the wave it receive. You reflect the wave receive. Understand? This reflect from an object moving at this speed. This is the velocity of observer. This object is the observer. Understand or not? This object become the observer. The moving object become the observer. It can reflect the wave. It can reflect the wave he receive. Okay. This object is the observer. This moving object is the observer, or we can say it's a moving observer towards the source. You say that towards the source. This observer is moving towards the source. So this 3.5 become the observed velocity. It become the velocity of the observer. Velocity of the observer towards the stationary source. Okay, we can imagine this observer is just like a wall that reflect the wave you receive. Okay. So, and then what's happening is okay, what's happening, the second situation is, what is the frequency of the wave reflected by the moving object as detected by a detector at rest near the source? This is the second situation. This is the second, how to draw? This is the second situation. This one is situation 2. This is the situation 2. Okay, maybe just okay. Situation 2 is maybe let me write up for you. Maybe let me draw for you first. See, this is the second situation. This is what happening in the second situation. Okay. So just now the first situation we changed already. This is the first situation. Stationary source is actually called the source 1. Yeah, source 1. Okay, and the moving observer, the wall, is observer 1. Okay, that is for first situation. What we can say is this wall is receiving the wave emitted by the source 1. Yeah, receiving the wave from the source 1. Okay, so the wall is the moving observer moving towards the source. And then the second situation is, what is the frequency of the wave reflected by the, you see, reflected by the moving object. This is the wall. The wall is the reflector, detected by a detector at rest near the source. So there's a detector near the source 1. Detector near the source 1. So this is the second situation. Second situation is, last time the first situation is the wall received the wave from the source 1, receive the wave. Now it reflect this source, this observer, it reflect the wave it received, reflect back the wave back to the source 1, and also reflect the wave to the detector, because the detector is just beside the source 1. Understand or not? So last time the observer, the moving object, which is the observer, has changed role to become a source. Why it changed role to become a source? Because you reflect the wave. When you reflect the wave, it's like you emit the wave. So you as a reflector, you are actually functioning like a source of the sound, like the source. Okay, when you reflect wave, that means you like emit the wave. You become the observer 1, become the source 2. You see, this observer 1 has become the source 2. It has become the source 2. Why the observer 1 become the source 2? Because it become the reflector. So last time he is a moving observer towards the source, Now he become a moving reflector. Yeah, he become a moving source. Last time is a moving observer, now become a moving source. Observer 1 become a source 2. Okay, so just last time the VO 3.5. Now this 3.5 value has become the speed of source. This one has become the VS. Understand or not? So use the same value. This one VO last time is 3.5. Now the VS also 3.5. Because last time the moving observer now has become the moving source. Why he become from observer become the source? Because last time in situation 1, he received the wave, he observed the wave from source 1. Okay, that's why he's a moving observer. Now he reflect the wave. He become the source. He become the source. He reflect the wave, he become the source. So this velocity become the source velocity. So it's like now it's like source moving towards the detector, moving towards the observer 2. Detector is the observer 2. Understand? So VO become VS. Okay? The reflected wave. Reflected wave means when he reflect wave, he become the source. Source 2. Yeah? This. Okay? Alright. So we have two situations here. So there are two equations we need to do. Okay? We do one by one. Okay. So let's do the first one. This is the observed frequency equal to this the source frequency. Okay. So and then what's the formula? Source is stationary. Source is stationary, so we don't have Vs. We don't have Vs. So below here is just V. So at the top we have VO because it's moving observer. Moving observer. So we have VO. And the observer is moving towards. Observer is moving towards the source. Observer moving towards the source. So we can what can we say is, what is the frequency hertz? So the observed frequency, okay, so this here the source, it has the actual original source frequency. So what is the frequency heard by the observer, the moving observer? You are moving towards the incoming sound wave. So of course, if you're moving towards the sound wave, of course you hear a higher observed frequency. Higher observed frequency. Because why? Because you are moving towards the incoming sound wave. The wave will passes through the observer much faster. More wave passes through observer faster. So your observed frequency is increased. Observed frequency increase. Understand or not? As long as moving towards, no matter is observer moving towards or source moving towards, the observed frequency always increase. Understand or not? Moving towards, always observed frequency increase. So for this one, this value at the top, need to become bigger. How to make it bigger? Positive, we plus we become positive VO. This value at the top become bigger, so the FO become bigger. That's how we do it. Now we substitute the value. So what is the V? What is the V value? Speed of sound. This is the value here. This is the speed of sound. Understand? So we have 345. Bottom here is also 345. Plus VO is 3.5. All in SI unit, isn't it? Meter per second. Meter per second. You must always check the unit. Or in SI unit. Okay, and then Fs is the original frequency is 5000 Hertz. Original frequency. So the source is moving towards the observer is moving towards the source. So you will hear a higher frequency, higher observed frequency. Okay, so let's calculate. Okay, what's the answer? I got the answer 0.5050.725 Hertz. You hear a higher observed frequency. You mean the wall, the observer receive a higher frequency, a higher observed frequency because it's moving towards the source. The wave coming faster, the wave coming faster, more wave coming faster. So observed frequency become increased. And this observer, this wall, reflect all the incoming wave. So he become the source too. Understand? So now become the source too. We do another process. Now the observer is stationary. Now the situation 2, the observer, the detector, the observer 2 is stationary. The wall that reflect the wave, is the source 2 is moving towards the detector, So the wave is being compressed. We can say the wave is being compressed. So the observed frequency should further increase because the wave is being compressed. Because the source is moving towards the detector. So the reflected wave is being compressed. The wave is being compressed, so the observed frequency should further increase. Because source moving towards, the observed frequency should increase. Okay, so this is a observed frequency prime lah, number 2. You should further increase. Okay. Okay, now what's the equation? Let's write down the equation. Okay, now do we have VO? Last time we have VO, now do we have VO? Is the observer moving? No, the detector is stationary. The detector is at rest. You see that? The detector is at rest. Detector at rest. So the observer 2 is at rest, not moving. VO is 0. So detector at rest. So at the top, we only have V because the detector is not moving. But the source, the reflector, the source 2 is moving. The source is moving. So we have VS. We have VS at the bottom. Okay? We have VS at the bottom. This one, frequency of source, we use the frequency reflected. This one is prime. Because he reflect the wave received. Yeah. Why F? This one he reflect. This is the frequency he reflect. Understand? This is the frequency he reflect. This is the frequency he reflect. This is the reflected frequency. Understand that? 5050 is the reflected frequency. Reflected source frequency. Okay? 5050. So this one, this value, we no longer use 5000. We no longer use 5000. We use 5050 to put in here. Okay? Because he only reflect the frequency he received. He actually should receive a higher frequency. So he receive a higher frequency. He also reflect a higher frequency. So this one you should put. This one you should put 5050.725. Understand? Not 5000. Okay. But now the source frequency is moving towards the observer. So the wave is further compressed. So the detector should hear a even higher observed frequency. So the observed frequency, the source is moving towards. So the observed frequency should increase. So how to make the value below here need to make smaller. How to make it smaller? Minus. We minus the VS. So this value, the denominator becomes smaller. So divide by a smaller denominator. This observed frequency should increase. This is the FO prime lah. I should put, yeah. So okay, let's continue. So this is above is 345. Below here is 345 minus the VS. VS also 3.5. Last time the observed velocity now become the source velocity. Okay. Because it changed role from observer 1 becomes source 2. Understand? So this one is 5050.725. Okay. So what do you get in the end? What do you get in the end? So let's calculate 345 minus 3.5 and then 345 divided by answer times 5050.725. Okay, so the answer is 5102.49 Hertz. Even higher detected frequency by the detector near the source one. Okay, so that's the answer. Okay, so that's the answer for these questions. Not given, but I can imagine lah. So what I can say is no matter is observer moving towards or source moving towards, yeah, observer moving towards or source moving towards, the observed frequency should always increase. Just like this one lah. Yeah, no matter is source moving towards or observer moving towards, the observed frequency should always increase. But if the source is moving away, or the observer is moving away, and no matter who moving away, the observed frequency should always decrease. So remember this. Alright, so that's all for this question. Bye.